Now only I have written it. So here the question is, if the integration, can you see the screen first? Let me know. The screen
Yes.
is visible. Okay. Okay, let's move ahead. So the question is, if the integration of dx over x square minus 2x plus 10 whole square is equals to a tan inverse x minus 1 by 3 plus f of x by x square minus 2x plus 10 plus c, then the value of a and the value of f of x we have to find. Okay, here one statement is there, then a will be what will be the value of a and what will be the value of f of x. So that's what given in the option. So we have to solve the integration which is given on the left hand side, and we will be arranging it according to the given right hand side, and then we will be saying that what exactly is the value of a and what exactly is the value of b. Let's solve it. So we are having our integration dx over x square minus 2x, just a second, minus twice x plus 10 whole square. Now, whenever we are having such expression in the denominator, what we try to do? We try to do the factorization, we try to do the splitting in middle term, or whatever is possible, that's what we try to do. Okay, the factorization is the first thing which will come in mind. So here, let's see whether factorization is possible or not. So here I can see 10 is there. Is it possible to split the middle term? Whatever you will do the factorization of 10, 5 into 2, we will not get 2, right? So the other approach we need to apply here. Are you getting it? That it is not possible to split the middle term and do the factorization. If that is possible, then one way is there. If that is possible over here, then what we can do? We can just split the middle term, the square which is there outside, that power 2 we can give to each and every factor, and then maybe by the method of partial fraction decomposition we can do it, right? So let's move ahead and let's try another approach. So what can be the other approach? So dx by, can we make it perfect square? So here x square is there, not plus, minus is there. Minus 2a, b is 1. Okay, plus 1 is square, minus 1 is square. I am making it perfect square. Plus 10, that's whole square. Okay, it will give us dx over whole square, because minus 2ab is there, and here we are having negative 1, positive 10, which will make plus 9. The completely there is a power 2. Okay, which I'm just copy pasting from the previous step. Let's move ahead. So this is what we are having. Just a second. Yeah. So dx over x minus 1 whole square plus this 9, I can write it as a 3 square, but there is one more power 2. Now we will try to do the, here it doesn't look like any formula. So far it doesn't look like any formula. What we try to do while doing the integration, we try to make the formula which will be easier to apply. A certain set of formula we are having in hand, and every time whatever be the integration, we try to reach to do any of the formula so that we can easily apply the formula and we can solve our question. So far at this point, it doesn't look like any formula which we have memorized. So maybe substitution we have to do for now. So what substitution we can do? If we will take x minus 1 as, if we will take x minus 1, if we will do trigonometric substitution, let's see will it work. So trigonometric substitution, we are having identities. identity, that is sin square theta plus cos square theta is equals to 1, sec square theta minus tan square theta is equals to 1. So if we will take tan theta over here, what are we going to get? Here we will be getting dx is equals to sec square theta d theta. So if, okay, not only tan theta, we need to take 3 tan theta. So then only this 3 we will be able to take out as a common. Okay. So it will become 3 dx is equals to 3 sec square theta d theta. Let's write it over here. So this dx will become 3 sec square theta d theta. And in the denominator, we have assumed this x minus 1 as a 3 tan theta. So tan theta's whole square plus 3 square and complete square. Okay, let's move ahead. We'll be having 3 sec square theta over. Now from this part, if we will be taking 3 square common, here also we are having 3 square, here also we will be having 3 square. So if we will take 3 square common, we will be having tan square theta plus 1, right? That means successfully we have made the formula. Which formula? The identity, that is sec square theta minus tan square theta is equals to 1. That means 1 plus tan square theta we can write over here. Okay, d theta I'm missing over here. Here d theta is there. So we will be having 3 sec square theta d theta, and in the denominator 3 square is there. Okay, this tan square theta plus 1 will become sec square theta, but we must not miss this power 2. Okay, now let's take it out everything from the curly bracket and just distribute the power. And in the denominator we will be having 3 square is already there, and it will take one more power 2, so it will become 3 to the power 4, right? It will become 3 to the power 4, and this sec square will become sec to the power 4. Can we move ahead? Okay, let's move ahead. So we will be having this 3 and 3 will go, so 1 by 3 cube still we are having, and sec square theta will cancel out, 1 sec square theta from the denominator, so we will be here, which can be written as cos square theta in the numerator. Now this type of integration you must have done, right? Whenever we are having this cos square theta, what we do, we try to write the formula of cos 2 theta, right? Let's write it. So we know we are having one formula, that is cos minus 1, right? Is it so? Have I written this formula correctly? Are you aware of this formula? Everyone familiar with this formula, yes or no? Let me know.
Ma'am, shouldn't it be cos theta?
Where?
Cos 2 theta is equal to 2 cos theta.
Is it so? 2 cos theta minus 1. Rest of the student, is it so? Cos 2 theta is equals to what?
Cos square theta minus 1. 2 cos square theta minus 1.
Yeah, this is what we are having. One more formula is, or two more formula is there. One is 1 minus 2 sin square theta, and one is cos square theta minus sin square theta. So these three formula we are having for cos 2 theta, right?
Ma'am, that 2 cos theta minus 1, it should be like that, yeah.
Is it so? The formula is 2 cos theta minus 1. Cos 2 theta is equals to 2 cos theta minus 1. I have written both the part, like which I am saying that it will be 2 cos square theta minus 1, and you are saying it will be 2 cos theta minus 1. Is it so?
Ma'am, is that square root 2?
This is a square.
Okay, then.
Then it's correct.
Yeah, I have written a square. Okay, power is 2. Let's move ahead. That means it's my fault only. I have not written it properly. So it will be 1 by 27. Here also it's power 2, okay? This is power. So here cos square theta is there. I want to replace this one by using cos 2 theta formula. So by 2. Okay, this is what I am going to write over here. Cos 2 theta plus 1 by 2 d theta. Let's move ahead. We will be having 1 by 27. Why it's lagging? My voice is clear to all of you. Like, am I audible?
Yes. Yes, ma'am.
Let me share it again. I don't know why it just stopped. In between it's lagging. Okay, let me know if it is going to continue like that. Can you see the screen for now?
Yes, ma'am.
Okay, let's move ahead. So let's do it quickly. Okay, we need to find the answer steps we are doing for ourselves, but at the end we have to mark the correct answer. So we will be doing it quickly. Cos 2 theta, what will be the integration of that?
Minus sin 2 theta divided by 2.
Is it minus sine 2 theta or what?
Plus sin
Only
plus
sine 2 theta.
plus.
Plus, right? Divided by 2, can I write? Can I write this 2 theta is there? That's why divided by 2.
Yes, yes, ma'am.
Yes or no?
Yes,
Plus
ma'am.
1 by 2, only theta. Okay? Plus obviously constant of integration will be there. Let's move ahead. So we are having 1 by 27 and here 1 by 2, 1 by 2. Okay, let's write it as it is. 1 by 27. Here we are having sine 2 theta over 4 plus 1 by 2 theta plus C. We will be doing back substitution. See our options first. I don't know why it is happening again and again. See the options. Here option is A value is given. Okay, before seeing the option, we need to keep our eyes on the left, the right hand side. That is A tan inverse x minus 1 by 3 plus f of x by x square minus 2x plus 10. This is how we need to arrange our answer. Okay, and then only by doing the comparison, we will be able to say what is the value of A and what is the value of f of x. Okay, so what we have done for substitution, we have taken x minus 1 as a 3 tan theta. Okay, let's do the back substitution. We have taken x minus 1 is equals to 3 tan theta. So if we need to write the value now, if we have to do the back substitution for theta, we will be having x minus 1 by 3 and tan inverse for theta. Okay, is it clear how I'm writing this theta? And here we were having plus 1 by 2 theta plus C obviously. So 1 by 27 sine 2 theta by 4 plus 1 by 2. At the place of theta, I am going to write tan inverse x minus 1 by 3. But we also need to do something over here, sine 2 theta. If I will write sine of tan inverse, that will not make sense, right? Here options are like a value is there, b value. If tan inverse of tan we can make, that's what we always try to do, so that tan inverse and tan will just neutralize each other and we will be having x. Okay, so here sine 2 theta, do we have any formula for sine 2 theta which is related to tan? Do we have any formula for sine 2 theta in terms of tan? Yes or no?
So tan theta by 1 plus tan square theta.
Yes, that formula we will be writing here. Why we are going to use this formula? Because theta, now only we will be substituting tan inverse. So if we will be having already tan outside, it will just make everything easier. So 2 tan theta by 1 plus tan square theta, you should know all the trigonometric formulas. So here we'll be having 1 by 27 and sine 2 theta. I'm going to write, okay, 1 by 4, let me write it over here. Sine 2 theta, I'm going to write as a 2 tan theta by 1 plus tan square theta plus 1 by 2 tan inverse. Go ahead. This 2 will cancel out. 4 will be having, and tan of now theta. That means tan inverse x minus 1 by 3. Here also 1 plus tan of tan square theta. We can write it as a tan theta's whole square. It's the same thing. Sin square theta means sin theta's complete bracket you can write, and then you can write power 2. Okay. So tan theta, tan square theta is there. So I'm going to write tan theta's complete square. That means tan theta will be tan of tan inverse, and then just a moment, no, just give me a don't know what is happening today all of a sudden. So we are having here, okay, whatever I have written, everything gone. I'm just writing the last step directly. Okay, let me know whether it is making sense to you or not. So we were having tan theta, we have replaced by, here we are having x minus 1 by 3 in the numerator, because tan and tan inverse just neutralize each other, and in the denominator we are having 1 plus tan square theta is there. So tan theta, and then inside this theta we are replacing tan inverse x minus 1 by 3. So basically whole square. Okay, plus the other term is as it is, tan inverse x minus 1 by 3. Let's move ahead. From here we can take out 1 by 2 common, I can see. So we can take out 1 by 2 common. We will be having 1 by 54. 7 2 times 14. Yeah. Yeah. And here we'll be having x in the denominator. If we will do the if we will do the simplification by applying the formula of a minus b whole square, what we'll be having? 1 plus, that is a square minus 2ab plus b square by 9. Okay, here 1 by 2 tan inverse x minus 1 by 3, and the constant of integration is still there. One by 54 calculation. So 9 will come out as a LCM of the denominator, and here we'll be having for the denominator 9 plus x square minus 2x plus 1, and this 9 will go in the numerator. If you will do the reciprocal, you can do it in your own. It will go in the numerator here, x minus 1 by 3. This is how we'll be having. Okay, 3 times 9 plus, okay, 1 by 2 already I have taken out common. So tan inverse x minus 1 by 3. Let me know if any step is not clear to you. X minus 1, in the denominator we will be having x square plus 10 minus 2x. Okay, again it is stopped. I don't know what is happening. So let's see which option is the correct option. We are almost there. We have found everything. Now we need to just see the options. Just a moment. Now I'm sharing the screen. Now I believe the problem will not occur. Okay, let's continue it over here. So the options, okay, we are trying to write it in this format: a tan inverse x minus 1 by 3 plus f of x over x square minus 2x plus 10 plus c. We were already getting this x square minus 2x plus 10 in the denominator as our first term. Outside we were having 1 by 54 in that question. Now only I'll be sharing that page. For as of now I am unable to share, so that's why I'm continuing it over here. Tan inverse x minus 1 by 3 is our this one we were already having as the second term. So here it is written as a first term. No worry, a plus b or b plus a is the same thing. So we got that pattern. F of x, we have to say what is f of x. A, we have to say what is a. So what we will be doing over here, a we can see clearly it is 1 by 54. Let me see the options are given like that or not. Yeah, options are also given like that. We were having, let me write what we were having in the previous step. So this is our step. There we were having x3 x minus 1 in the numerator, and in the denominator we were getting x square minus 2x plus 10. Here we were having tan inverse x minus 1 by 3. This is what we were having in the previous step. Now we have to compare it with this one, which is given in the questions right hand side. So we can say a is 1 by 54, right? And what about f of x? So we can say f of x is 3 multiplied with x minus 1. So this is what we are having at the place of f of x, and this is what we are having at the place of a. One option is there already. Okay, option number C. Yeah. Option number C is that only, that a value is 1 by 54 and b value. Yes, now I can say it. Just a moment. Can you see the options? First, see the question. If integration of this is equals to this, then a and fx value we have to see. So can we say here that option number C is the correct option?
Sure.
Okay, so we are done. What we have done here? Nothing. We have just, first we were trying to do the factorization. That was not possible. What we did, we have made the perfect square. After that, we were thinking about what to do the substitution. But the question is indicating that tan inverse is there. So maybe we will be taking tan theta and that will work. And yes, that worked also. Okay, and we have got our answer also after doing this all the steps. Let's take another question. If we are having integration of under root 1 minus x square over x to the power 4 dx is equals to ax, again under root 1 minus x square to the power m plus c, for a suitable chosen integers. There here m is integer and a function ax. Ax is a function. C is a constant of integration. We have to find here a x power m equals, options are given. Option A, 1 by 9 to the power 9x to the power 4. B, negative 1 by 3x cube. C, negative 1 by 27x to the power 9. and D 1 by 27 x to the power 6. Let's see what can be done over here. Here also we have, first we have to find ax, first we have to find m, and then we have to do this calculation, whatever is asking. Let's do the integration first. So we are having integration of under root 1 minus x square, yeah, by x to the power 4. So we are having under root 1 minus x square by x to the power 4. What can be done over here? Any idea? Anyone?
Can put substitution method.
Substitution. So which substitution we can take over here? Here the other part is not indicating. It's just under root 1 minus x square. If we will take x common from here, x square common from here, we will be having 1 by x square minus 1 over x to the power 4 dx. Okay. After that, this x square which we have taken out common inside the root, if we will take it out, that will become x only outside. And inside the root, we will be having 1 by x square minus 1 over x to the power 4. Are you able to see the pattern? See, this x and this x to the power 4 together by doing the division will make 1 by x cube. And if we will take this as a substitution, everything from here, we will be getting 2 by x cube, right? Yes or no? So this will become very easy. If that is working, we have to check. If that is going to work, then this integration will become very simple. Let's see whether it is working or not. So if we will be having this x, this two circled part is making x cube in the denominator. Okay, and here we are having 1 by x square minus 1. If we will be assuming 1 by x square minus 1 is equals to t. Why t? Let's take t square because the square root is there. So if we will be taking a square, that will help us to just get rid of this square root sign. Okay. So what will be the derivative of this part? So negative 2 by n x to the power n minus 1. Will it be x cube? Dx is equals to 2t dt. Is it so? Yes or no? This 2 and this 2 gone. We are having dx by x cube. We will be keeping on one side, and the other side I am writing minus t dt, because here we can see we are having dx by x cube. Okay. So let's move ahead. We will be having negative t dt, and this square root term we have assumed that as a under root t square. So from there one more t will come out. And yeah, that's it. We are having nothing else. So we can just do the integration. That is t square dt will be t cube by 3 plus c. Is it clear so far? Are we missing anything? Let me check. No. So we got minus t cube by 3 plus c. Now we will be doing the back substitution. What is t? T is under root 1 by x square minus 1. T is under root 1 by x square minus 1. That is t, and whole cube we will be taking, over 3 we will be taking, plus c we will be taking. We have to check our right hand side also. Is it possible to make it like that? So under root 1 minus x square. Yeah, under root 1 minus x square we will be getting. Outside ax is also there. Let's try to make it like that only. So we will be having, just a moment. Here we can write it like under root x1 minus x square over x square, and power 3 is already there. by 3 plus c. Okay, let's move ahead. So this, the denominator's x, we can take it out, this one. So from the square root sign, if we will take it out, that will be only x. Okay, so we will be having only x, but this power 3 it will take, so it will become x cube. And then we'll be having 1 minus x square, that's power 3. Over 3 is already there, plus c. So we ended up getting minus 1 by 3 x cube here, under root 1 minus x square to the power 3 plus c. Let's see. 1 minus x square. M value we got as a 3, right? Ax we got as a minus 1 by 3x cube. And if we will do the calculation, which is just asked in the question, ax to the power m. So if we will do the same thing, if we will do it, ax is minus 1 by 3x cube. And that's power m, that means 3. What we will be having? 3 times 9, 3 times 27, negative 1 by 27, and x to the power 9. Let's check. Option C is the correct option. Can you see? Are you getting it?
Yes, ma'am.
So whenever we are having such term, like if we have to do integration for this, if this type of integration we are having, we will always try to substitute something so that we will end up getting the another part. Okay, so that, for that obviously we have to do the arrangement, and we have to think what can be done so that one part we will be doing the substitution and rest part we will be getting after doing the derivative of the substitution. Okay, so let's do the next question. Let me know if any confusion you are having over here. Yes, the next question is also like this only. Let me know which, like how we can do it. It's like that only. We will be trying to do the arrangement and then we'll be doing the substitution, not trigonometric substitution, normal substitution after doing the arrangement. And then we will be getting the other part after doing the derivative of the substitution. So here we are having 2x to the power 11 over 2x to the power 4 plus 3x square plus 1, that's power 4. Yeah. What exactly here also a, b or anything is there? Just a moment. No, only the options are there. Just do this integration and find the answer. It is from 2019. So option A is there, that is x to the power 4 by 6, 2x to the power 4 plus 3x square plus 1, that's cube plus c. Option B is x to the power 12 over 6, 2x to the power 4 plus 3x square plus 1 whole cube plus c. Option C is x to the power 4 over 2x to the power 4 plus 3x square plus 1 whole cube plus c. And option D is x to the power 12 over 2x to the power 4 plus 3x square plus 1 whole cube plus c. These four options are there. Here we just have to do the integration and we have to check which option is the correct option. We don't have to find a value or f of x value or maybe m value. Nothing is given over here. So let's do the integration. We are having 3x to the power 13 plus 2x to the power 11, and in the denominator again we are having this power. Okay, we will try to do the factorization, but see, that is that possible over here? No. So what can be done? We are having 3x to the power 13 plus 2x to the power 11. In the denominator we are having 2x to the power 4 plus 3x square, 2x to the power 4 plus 3x square plus 1. again power 4 was there, yeah, and that dx. We will try to apply the substitution method. Only one part we will substitute and we will get the another part as a after doing the derivative, but before that we have to arrange it like that. So what can be the possible arrangement? So here in the previous one, what we tried to do, like we tried to do 1 by x square, and that was giving us minus 2 by x cube, right? Here we can see x is there in the numerator, x is there in the denominator also. So let's take x common and let's cancel out as much as x which is possible. So what we can do here, if we will take out x to the power 4 common from the denominator, that will again take power 4. Okay, because I'm just completely taking it out from the bracket. So it will become 2, only 2 plus 3 by x square plus 1 by x to the power 4, power 4 over here. Any confusion so far? Let me know. Why we did so? We are trying to cancel out x, as much x which is possible. In numerator, the first term is having 13, x to the power 13. The second term is having x to the power 11. If we will take common factor, x to the power 11 will go as a common factor. So to cancel that, we need something in the denominator also, right? So here we are having x to the power 11 as a common factor. Here we will be having 3x square, yeah, plus 2 dx. Now this x to the power 16 in the denominator and x to the power 11 in the numerator will cancel each other. One more thing we can do without taking common out, we can, whatever we have taken it out from the denominator, we can take it with the numerators each and every term. Let me show you how. So we can do like this. We can take 3x to the power 13 by x to the power 16, which is sitting in the denominator. I am taking with the first term, plus 2x to the power 11 by x to the power 16 over 2 plus 3 by x square plus 1 by x to the power 4. And here we are having one more power. What we are getting from here? We are getting 3 by x to the power 3 plus 2 by x to the power 5. Now what I say, either we will take the substitution, the denominator we will substitute and numerator we will get, or maybe numerator we will substitute, denominator we will get. So check it, what is happening over here. Check it. We are having 3 by x square plus 1 by x to the power 4, and here we are having power 4. Can you see, if we will substitute this one, are we going to get the numerators part, x cube in the denominator and then x to the power 5 in the denominator? Yes or no? Forget about the coefficient which is there in the numerator, 3 and 2. We are just trying, for now we are trying to see if we will substitute the denominators part as a t. Okay, and then we will be doing the derivative. Then is it possible to get something by x cube and something by x to the power 5? Yes or no? Let's take it as a substitution. So if we will be taking 2 plus 3 by x square plus 1 by x to the power 4 is equals to 2t, it will become 2 is 0. This will become minus 2 by x cube, and 3 is already there. So minus 6 by x cube. Here it will be minus 4 by x to the power 5. Okay, it will be minus 4 by x to the power 5. That dx is equals to dt. Okay, now we can write it as, if we will take out minus common, and if we will take out 2 common, we will be having 3 by x cube plus 2 by x to the power 5. Dx is equals to dt. Can you see exactly the bracket term we are having in the numerator? Can you?
Yes.
Obviously, the question will be framed in such a way so that it will follow a pattern. Okay, we just need to understand the pattern. two question you have seen where we are taking out x common, making it a fraction, and then we are taking the substitution, and then easily the substitution is giving us the result. Okay, so 3 by x cube plus 2 by x to the power 5 dx is equals to dt by 2 negative 2 we can say. Let's take it. So we will be having minus dt by 2, and the denominator we have assumed everything as a t, so it will be t to the power 4. Let's move ahead. So minus 1 by 2, we will be having t to the power minus 4 dt like this. So n plus 1 x to the power n plus 1 by n plus 1 will be taking. So negative 1 by 2 t to the power minus 4 plus 1, that will be minus 3 over minus 4 plus 1, again that will be negative 3, right? Plus constant of integration, of course this 3 and this negative negative will absorb with each other. We'll be having 1 by 6 t to the power minus 3, we can write it as a 1 by t cube. What is t? T is 2 plus 3 by x square plus 1 by x to the power 4. T is 2 plus 3 by x square plus 1 by x to the power 4. That's power 3 plus c. Let's see the options. Okay, that means still we need to simplify it, because in the option the denominator's term is not the rational. Here we are not having the rational term, okay, for the denominator. That means we have to do the simplification, and whatever is extra that will be shifting to the numerators part. So we will be having 6 1 by 6 as it is. Here we will be having 1 by, we will take the LCM will be x to the power 4. Here we'll be having 2x to the power 4 plus 3x square plus 1, everything cube we have to take, plus c. So this, the denominators part, once you will do the reciprocal, first distribute the power. Okay, so we will be having 1 by 2x to the power 4 plus 3x square plus 1, that will take a cube, and this x to the power 4 will also take cube. So 4 3 times 12, that will go in the numerator. So we will be having x to the power 12 in the numerator. Okay, this is power 3. Okay, please don't get confused. Plus c. Let's see which option now. Is there any option which is exactly like this? So we are having x to the power 12 in the numerator. The denominator is 1 by 6 is there. And then 2x to the power 4 plus 3x square plus 1. And cube we are having. This is the correct option, right? Yes or no?
Yes, ma'am.
Let's move ahead. So in this part, in this indefinite integral part, nothing extra we are learning. Okay, everything is already known to you. That too you have done in class 12 only. Freshly you know everything. You just need to practice a lot of questions. Okay, so the next question we are having. The integral of sin square x cos square x over sin to the power 5x plus cos cube x sin square x plus sin cube x cos square x plus cos to the power 5x, that's square dx. And the only integration we have to do, options are given as 1 by 3 1 plus tan cube x minus 1 by 3 1 plus tan cube x plus c. Option C, 1 by 1 plus cot cube x plus c. And option D, negative 1 by 1 plus cot cube x plus c. Okay, this is what we are having the integration, and the options are given over here. Let's see what can be done. Okay, So let me write it again. We are having sine square x cos square x, and here we are having sine to the power 5x plus cos cube x sine square x plus sine cube x cos square x plus cos to the power 5x, and completely power 2 is there. Okay. Options are tan, tan, cot. Okay. Here, if you will see carefully the denominator, sine to the power 5, then again cosine term, then again cosine term. If we will try to do the factorization, if we will try to take common factor, 4 terms are there, 1, 2, 3, 4. So the pair we need to search. Is it possible or not? That is the first thing we will think, because we are having few identity in mind. If after taking the common factor identity or anything will work over here, that will be the best. Let's see whether it will work or not. So if we will take from this two, okay, whatever is given at first thing first, we will be checking very like easier way. If from this two, if we will take sine square common, we will be having sine cube cos cube. From this two, if we will take cos square common, we will be having sine cube cos cube. Okay, so the pattern is going on. Okay, you can see the pattern, it's following the pattern. What we try to do when we take the common factor, the first bracket, the second bracket needs to be same. That's what that is every time we apply while doing the splitting the middle term, we make the both the brackets same, and then again we take the common factor. So the same thing we will be doing over here. From the first two term, I can see if we will be taking out sine square common, we will be having sine cube x plus cos cube x. And from the second two term, if I am going to take cos square x common, then again it is giving us sine cube x plus cos cube x. Yes, we are able to factorize it. Okay, we are able to take the common factor. Dx is there. So sine square x cos square x in the numerator, and in the denominator, one bracket will be having sine cube x plus cos cube x, and another bracket will have sine square x plus cos square x. We know this sine square x plus cos square x is 1. Okay, so we are just left with sine cube x plus cos cube x, that's whole square in the denominator. So sine square x cos square x dx over, here we are having in the denominator sine cube x plus cos cube x, and that's the square. Now again we will try to do the substitution, because for now we are not getting anything. Okay, so what substitution we can do? If we will take the denominator, is it possible to get the numerator? For now it's not possible. Okay, 3 sine square x we will be getting, then sine x again derivative will do, that is cos x we will be getting. So extra term also we will be getting. Now what can be done? In the answer part, we are having tan, cot we are having. So if we will try to make it tan, we will be having, if we will divide the numerator and the denominator with, or better, let me write, if we will take out common cos cube x from the denominator, here we will be having tan cube x, here we'll be having plus 1, but be careful, everything is having power 2. Is it clear? For the denominators part, whatever I have written, is it clear?
Yes, ma'am.
In the numerator, whatever we are having, let's write it as it is, sine square x cos square x dx. Let's move ahead. So we will be having sin square x, cos square x, and in the denominator this cos to the power 3x will become 6 cos to the power 6x. Okay, this will become cos to the power 6x, and here we will be having tan cube x plus 1, that's a square. Cos to the power 6 and cos square, it will cancel out, one this power and this power will go here, we will be having power 4 remaining. So sin square x by cos square x, 1 we can take together, that is tan square x we can write in the numerator, and 1 by cos square x is left, that means sec square x we can write. Let me know this step is clear to you or not. Directly I have written after just doing the cancellation and everything.
Yes, ma'am.
Okay, let's move ahead. Now we know we will be taking tan common and we will be getting the sec. But is it possible to take everything from the denominator as a substitution? So tan cube x plus 1 is equals to t. If we will take, we will be getting 3 tan square x, and tan x chain rule will be sec square x. Yeah, we are getting, can you see? So we got tan square x, sec square x, dx is equals to dt over 3. Okay, this is the numerator's part became dt over 3, and the denominator t we have assumed it became t square. Let's do it. So t to the power minus 2 will be t to the power minus 2 plus 1 by minus 2 plus 1. That means t to the power minus 1 by minus 1. So negative sign will come into 1 by t will come plus constant of integration. Let's substitute t and then we will be checking the option, because in option also say tan and cot was there. Okay, so let's do the substitution, the back substitution. We will be having 1 by 3, negative 1 by 3, and t will be tan cube x plus 1 into 1 by tan cube x plus 1 plus c. So we are getting, this is the right option. Can you see? B. We are also getting negative in the numerator. We are also getting 3 in the denominator. Then 1 plus tan cube x we are having in the denominator. So can we say option B is the right option? Yes or no?
Yes, ma'am.
Is it clear? Any confusion so far? Let's say the next question we are having, if integration of f of x dx is equals to psi x. Have you seen this notation earlier? Yes or no?
Yes, ma'am.
Okay, so this is called psi. The Greek notation we are having, no, theta, phi. Okay, so like that only here we are having psi. So don't worry. Once you will see the question, and if this notation is, you are not familiar with this notation, you will leave this question. But just try to understand, this is nothing but just like a theta. It's theta x. Okay, or maybe phi x. Then x to the power 5, integration of x to the power 5 f of x cube dx is option A, 1 by 3 x cube psi x cube minus integration of x square psi x cube dx plus c. Option B, 1 by 3 x cube psi x cube minus 3 integration of x cube psi x cube dx plus c. Option C, 1 by 3 x cube psi x cube minus integration of x square psi x cube dx plus c. And the last option is If we will keep our eye on option, that will help us to solve the problem. That's why I am writing the options also. X cube psi x cube minus x cube psi of x cube dx plus c. Okay, these are the four options and the question is this one. If f of x dx is equals to psi x, then find the integration of this one. We have to find the integration of this, the integration which is given over here. So let me take that integration and let me take the condition also which is mentioned over here. So we are having the integration x to the power 5 f of x cube dx. This integration we have to do, but one condition is mentioned over here, that is integration of f of x dx is equals to integration of f of x dx is equals to psi x. Yeah, only psi x. So let's continue. So f of x cube is there. If we will take the substitution this x cube, okay, if we will take x cube is equals to t, then it will give us 3x square dx is equals to dt. That means x square dx is equals to dt by 3. So this x to the power 5, we can break it in form, one part we can write as a x cube, another part we can write as a x square. So let's write it. We can write this x to the power 5 as a x cube into x square and f of x cube dx. This is how we can break the terms in our integration. And this x cube we have assumed as a t. F of x cube, this is f of t. And this x square dx is dt by 3. So dt by 3. Any confusion so far?
No, ma'am.
No, ma'am.
Now can you see it looks like integration by parts we can do over here. We have done this type of integration. So let's do integration by parts. So 1 by 3, let's keep it outside. How we apply by parts? First function. What is the first function? We will be taking obviously this as a first function, because when we will do the derivative of t in the second part, it will be 1. So first part, integration of f of t dt minus derivative of t is 1 into integration of f of t dt, and everything's integration we have to do like this, right? Any confusion in this step where I have applied by parts?
No, ma'am.
Let's continue. We will be having 1 by 3. Okay, t we will be having as it is. Okay, so f of t dt we don't know. We know f of x dx is psi x. So can we say integration of f of t dt will be psi of t? It's the same thing, the function in terms of x, or maybe the function in terms of t, or maybe the function in terms of z. These are just the variable, right? Can we write f of t dt, integration of f of t dt is equals to psi t?
Yes.
Yes.
We can write, okay? So this one I am going to write directly without integration sign as a psi t, because that condition is given to us, okay? In minus, here again we will be writing psi t dt, okay, plus c. Let's see the options, okay? So the options are x cube, psi x cube, x cube, x cube, psi of x cube. So everywhere psi is having x. So let's do the back substitution. So at the place of t, I can write psi of x cube. Back substitution I am doing, nothing else. You can see here x cube I have taken t, so at the place of t I am going to write x cube. This t I am going to write x cube, okay, minus here psi of t, at the place of t I am going to write x cube. Let's see whether it is matching with any of the option. Still it is not matching. Can you see the first term we are getting? For first term we are getting x cube psi x cube, x cube psi x cube, x cube psi x cube, x cube psi x cube. First term is okay. We have got that. But we are confused with the second term, that we have got psi cube. We have already got psi cube, psi cube, psi cube. But this extras, this one we are not having. This one we are not having. dt we are having. Okay. Dx we don't have. See, if we will copy paste here, I will write dt. But is it possible to just write dt in, just convert dt in terms of dx? So yes, that is possible. Dt is, can you see, dt is 3x square dx. Let's write it.
Yes, ma'am.
Dt is 3x square dx. Let's see, again we will be matching with the options given. 1 by 3, if we will open the bracket, it will become x cube psi x cube, and this minus 1 by 3, and here also 3 will come out. That will cancel out each other. We will be having x square psi of x cube dx plus c. Let's check the option. 1 by 3 x cube psi x cube minus nothing we are having, and then x square. Okay, option C. Can you see?
Yes, ma'am.
So option C is the correct option. We have, what we have done, we have just written the integration, we have written the condition given, and we try to do the integration by taking this f of x cube is there inside function. How we write the function? F of x, g of x, h of x. This is how we represent the function. So here f of x cube was there, so we have taken that x cube as a 3, and then we have just written the substitution. Then we realize that okay, mm, we can use integration by parts over here. We have applied the rule, and then we have applied the condition, and we were keeping our eyes on the options given, and we are done. Okay, let's take the next question. A very simple question is there, which is let in is equals to tan to the power nx dx, where n is greater than 1. If I4 plus I6 is equals to A tan to the power 5x plus B x to the power 5 plus C, where C is the constant of integration, then the ordered pair AB is equals to, we have to find AB over here. Okay, when you will see this question, you will think that it is not, it's like not that simple. But when you will start solving it, it is that simple only. So ordered pair AB is 1 minus 1 by 5, 1. B is 1 by 5, 0. C is 1 by 5, minus 1. And D is negative 1 by 5, 0. Let's see what is given over here. So IN is this one. Then we have to find this one. Once we will find this part, then only we can just do the comparison with the right hand side. So I4 plus I6 we have to find, and then we will be doing the comparison, because a lot of question we have done like that. We have done the integration, and then we are comparing. We are finding the value of A, we are finding the value of B, we are finding the value of M and F of X, G of X, whatever. So let's do it same way. So I4 plus I6 we have to find, but it is given that IN is In is integration of tan to the power nx dx. Let me check. Yeah, that's what is given for in. So we have to find I4 plus I6. Okay, so I4 plus I6 will be what? We can take two integration, one integration for the I4, one integration for the I6, and then we can continue and we can do the integration. That's it. Yes, that's it. Okay, so what we will be doing, it will be tan to the power 4x dx, and it will be tan to the power 6x dx. We have to do the integration of this one, and we have to do the integration of this one. We know we can just separate the integration, so we can combine the integrations also. We can write both the tan to the power 4 and tan to the power 6 together. If separately you will try doing it, maybe you will end up getting confused. You will see what substitution you will be taking and then how you will be proceeding. It will take too much time. But what if we will be taking both of them together? Tan to the power 4x plus tan to the power 6x dx. From here, what is common? Common is tan to the power 4x. What is remaining? 1 plus tan square x. Yes, I can see the pattern. I can see the pattern that this will give sec square x, and we will be substituting tan, we will be getting sec, and we are done with the integration. Okay. So tan to the power 4x, 1 plus tan square x is sec square x dx. What substitution we can take? Obviously, tan x is equals to t. Sec square x dx is equals to dt. So we are having here what? T to the power 4 dt. T to the power 5 by 5 plus c. What is t? T is tan x. So we are having tan x to the power 5. That means tan to the power 5x. This is how also we can write it. Okay. What we have to find here? We have to find a tan to the power 5x plus bx to the power 5 plus c. A we can say a tan, we have to compare it with a tan to the power 5x plus b x to the power 5 plus c. C is okay, constant. A is also okay. We can say a will be 1 by 5. But b, we are not getting any term like that. We don't have any b. Let's see the options. B is 1, B is 0. Okay, so B can be 0 also. Okay, so maybe if we are not having B, that means maybe B is 0 only, and we have to check the correct option. So A, we are getting 1 by 5. We don't have any B. We can say B is 0. So okay, this option is the correct option, we can say. That's why one eye we will keep on solving the question, and another eye will be there on the option, and we will end up getting the correct option. Is it clear?
Yes,
Was
ma'am.
it was so easy, no? Only 2-3 steps we have done, and we are done with the integration. Here only we just need to understand, if we will take both the integration together, then we will be able to continue. How we will be able to understand all of a sudden in the exam? By practice only. Okay, if you have dealt with such a situation, then that situation will like come in mind. Maybe this will work, maybe that will work. We will be able to think about a lot of possibilities at that time. Now the next question. If we are having the integral 2x minus 1 cos of under root 2x minus 1 whole square plus 5, in denominator we are having under root 4x square minus 4x plus 6 dx. Integration we have to do. Okay, this is from 2021. Here c is the constant of integration. It's written in the question, and accordingly the options are there. That is 1 by 2 sine of under root 2x minus 1 whole square plus 5 plus c. Option B is 1 by 2 cos of under root 2x plus 1 whole square plus 5 plus c. Option C 1 by 2 cos of under root 2x minus 1 whole square plus 5 plus c. And the last option is 1 by 2 sine of under root 2x plus 1 whole square plus 5 plus c. Okay, let's see what can be done over here. Whenever we are having such expression in the denominator, whatever is there in the numerator, just keep it aside for a while. If we will focus on the denominator, what we try to do, making it splitting the middle term, if that is possible, making a perfect square, if splitting the middle term is not working, so at least we will try to factorize it. Okay, splitting the middle term still is not working, you can check it. 4x square is there and 6 is there. 6 4 times 24, break 24 in such a way so that we will be getting 4. Is that possible? No. Let's move ahead. We are having 2x minus 1 cos of under root, okay, 2x minus 1 whole square plus 5. In the denominator we are having 4x square minus 4x plus 6. Splitting the middle term we will not try also, because here can you see it is perfect square. So here also we will try to make perfect square. Maybe this under root, that under root, both will be exactly same. Maybe then we can take the substitution directly, the under root part. Let's see. So we can write it as 2x minus 1 cos of under root 2x minus 1 whole square plus 5. And in the denominator, if we will try to make it a perfect square, a whole square. You all know, no, how to make perfect square. This is how we make. Whatever is the square term, we write it. Then we see whether there is a plus sign or minus sign. Here minus sign is there. I am writing minus sign. Okay. And I will not look at this 4x. Okay. I'm not going to see that 4x. Okay. What I am going to do, I am going to make 2ab by myself. So 2 into a. What is a? 2x into b. So I will be writing such a b so that it will match with this term. So already it is making 4x. So b, I don't have any other option. I have to write 1 as a b. This is how I end up making 2ab. Now a square minus 2ab we are having in hand. Now plus b square we also need. So plus b square we will be writing by ourselves. Since we have taken plus b square by ourselves, we have to write minus b square also. Okay, plus 6 dx. This is how we do the perfect square. Here we are having 2x minus 1. You all know, I understand that you all know how to make the perfect square, but sometimes you get confused or sometimes you just forget how you were doing in previous classes. So here we are having cos of 2x minus 1 whole square plus 5. In the denominator we are having a minus b. So 2x minus 1 whole square, and this negative 1, positive 6 will make plus 5 dx. Yes, yes, we are getting the same term. Whatever we have expected, it is the same thing. So this is exactly we are getting over here. So let's take that substitution. We will be taking this complete, let's take as a t square, because the square root is there. So we will be taking 2x minus 1 whole square plus 5 is equals to t square. Okay. what we are going to get? 2 times 2x minus 1, and then chain rule we have to apply. So still we will be having 2. 5 will become 0. Dx is equals to 2t dt. 1 2 and 1 2 will go cancel out. So we will be having 2 times 2x minus 1 dx is equals to t dt. Are we having 2 times 2x minus 1 in the numerator? We are having 2x minus 1. Okay. So 2x minus 1 dx is equals to t dt over 2. Okay. Let's substitute it. So we got p dt over 2. This cos of under root something will become cos t, because the square root we have taken t square. So it will be cos t. And in the denominator, this under root, the bigger term, will become only t dt. Okay, t and t is cancelling each other, and we are having only cos t here. What is the integration of cos t? Is it minus sign or sign?
Sine.
Sign, positive sign. So we will be writing sine t. Okay, 1 by 2 sine t is under root 2x minus 1 whole square plus 5. T is under root 2x minus 1, that's whole square, plus 5 plus c. Let's check the options. 1 by 2 sine 2x minus 1 whole square plus 5. Option A. Can you see? Are we having the same? Yeah, we are having the same one. Option A is the correct option. We can say yes or no.
Yes, ma'am.
So far, whatever we have discussed, is that clear? Is that clear? All the questions, whatever I have taken today, is that clear to everyone?
Yes, ma'am.
Yes, ma'am.
Okay, just ma'am, should we do partial fraction? Yes, partial fraction is also there. Okay, a few questions are there. I'll be giving that partial fraction related to that question in the homework. You will be able to do. Okay, it will be very simple question. The way you have applied the method of partial fraction in class 12, same way you have to apply it over here. I'll be giving few questions from that portion also. Okay, and these are the questions which we have taken today. So do practice and let me know if you feel